Hello everybody, so in this video we will be looking at the tabulation or bottom-up approach of the LeetCode problem 62 unique paths. But before going into the video, I will recommend, if you haven't seen the previous video where I have discussed the basic of the brute force and the memoized code, you should watch that. I'll just go through the problem statement once again. So for example, if I have a grid like this, a metric like this, and this is my start point, I have to reach the last point, that is a grid of 2 2. So I have to find out in how many ways I can reach this point. So, and we are also given in the statement that I can either go right or I can either go down. So if I take a right, if I take a right, if I take a down, if I take a down, I reach my destination. If I take a down, if I take a down, if I take a right, if I take a right, I reach my destination. If I take a down, if I take a right, if I take a right, if I take a down, I reach my destination, and so on. This is what we have to do, and we have to return all the possible ways we can do this. So I have discussed the basic and the base case everything in the previous video. I'll provide the link in the cards as well as in the description, so make sure you watch that before watching this. So the base case for the recursive and the memoized was, if we consider this and suppose we have reached here, so we can reach the last position from this point or this point. So that is this point will be I minus 1 and this point will be j minus 1. So now for that, the base case was, if my I equals to 0 and my j equals to 0, then there is a way to reach from start to destination or destination to start. So that was my base case. We also had another base case. When for example, suppose I am here and I might jump out of this grid. So in that case, we don't have a way to reach from start to the destination or from destination to the start, so we will return a 0. So in the memoized, we took a DP array of size n m. So for the bottom up, what we will do, we will again take a DP array. We will again take a DP array of size n m, and we will initialize it to -1. That is our first, and our DP of 0 0 will be 1. Why we are doing this? Because our base case is, if my I equals to 0 and my j equals to 0, return 1. So this is this case here. Now from here, what we will do, as we have a matrix, we need to go over the matrix and find the ways. So we will traverse the matrix. We will use a for loop. For I equals to 0, I less than n, I plus plus, and from j equals to 0, j less than n, j plus plus. Since we have already calculated this, we can write a condition here. If my I equals to 0 and my j equals to 0, I'll just continue. What will continue will do, it will not evaluate the further things in the loops, and it will again start the loop for the next iteration. Okay, this was one thing. Or if it is not equal to 0, what we will do is, as we can go up, or we can go left. So what we can do, we can take a variable up equals to 0 and we can take a variable left equals to 0. Now there was a case, suppose if this is my grid and I'm here, from here, if I go left, I'll go out, 1 0 0 1. If I go left, I'll go out. So I can go left only for this, for except 0. If my I is 1 2 3 4 so on up to n, I can go left. And for this, if my for here except 0, I can go similarly for this. So I can write a condition, if my I is greater than 0, then my up is equal to dp of I minus 1 j. If you don't know how these values are coming, I'll again say that please watch the previous video. And if my j is greater than 0, my left will be dp of I j minus 1, right? in the end I have to return the sum of both of these. So my dp of ij will be up plus left, and when I come out of the for loops, and in the end I'll return my answer as dp of n minus 1 and m minus 1. So this will be my tabulation. These all conditions are derived from the memoized one. In memoized one we had function of, I was calling function of I minus 1 and j, and another function on I j minus 1. Similarly here we have a dp array instead of calling the function, so we are calling it on I minus 1 j and dp of I j minus 1. So now I'll take a small example and dry run this. So suppose this is my grid, a 2 cross 2 grid, 0 1 0 1, and I take a matrix of size nm. So n is here 2 and m is here 2, so 2 cross 2 matrix, right? So this is my dp array of size n cross m, and I have basically initialized it with minus 1 initially. And then what I did, I marked 0 1 0 1 dp of 0 0 as 1, so it is 1. Then I ran the for loop, and for I equals to 0 and j equals to 0, what I did, I continued. So now my j becomes 1. So I go in, I take my up as 0 and my left as 0. Then I check if my I is greater than 0. No, my I is equal to 0, so my up remains 0. Now I check if my j is greater than 0. Yes, my j is here, it is greater than 0. So then my left becomes dp of I j minus 1. So dp of 0 and 1 minus 1 0, this. So my left is this. In the end I'm adding up and left, so 0 plus 1 is 1, so dp of 0 1 gets the value 1, right? Now my for loops terminates and I go here. Now my I equals to 1, and for initially j is equal to 0, up equals to 0 and left equals to 0. Now we see, okay, my I is greater than 0, 1 is greater than 0, so my up becomes dp of I minus 1. I minus 1 is 0 and j is 0, so my up is 1 and my left is 0, as my j is here at 0. So in the end I add these two, 1 plus 0, it gives me a 1 here. Now in the next iteration, my I is 1 and my j is also 1. In the next iteration my I is 1, my j is 1, so I is greater than 0, j is greater than 0, so up will be dp of I minus 1 j, so 0 1, and left will be dp of I j minus 1, that is 1 0. So dp of 0 1 is 1 and dp of 1 0 is 1, so I add these 1 1 and I get a 2. And in the end I am returning dp of n minus 1 m minus 1, which is this position, right? So now if I see, I am here, I need to go here, I can take a right, I can go here, or I will do it reverse way. Here I am going here, I can take a up, I can go here one way, I can take a left, I can take a up, I reach my destination or start another way. So in the end I am getting 2, and similarly we are getting the answer 2 here. Now if I discuss the time complexity of this solution is, so in the memoized we got the time complexity as order of n square in the worst case, and the space complexity was order of n plus another order of n square. So it was my dp matrix, and this was my stack space that the function call was taking. But for the tabulation, my time complexity remains same as order of n square, but my space complexity decreases to order of n square, and we have omitted this stack space. So now let us just code this question real quick. So we are given m and n. What I'll do, I'll take a dp array, or I'll take a vector instead, vector of int of size m, I'll initialize it with -1 and dp of 0 0 equals to 1, or instead we can directly run a for loop for int of I equals to 0, I less than m I plus plus, for int of j equals to 0, j less than n j plus plus. If my I equals to 0 and my j equals to 0, dp of I j equals to 1. Else what I'll do, I'll take two variables, up equals to 0 as well as left equals to 0. If my I is less than 0, if my I is greater than 0, what happens, my up becomes dp of I minus 1 and j, and if my j is greater than 0, my left becomes dp of I j minus 1, and then what I'll do, my dp of I j equals to up plus left, and in the end I'll return my dp of m minus 1 and n minus 1. Now if I submit the code, okay, we got a compiler error. So what is the mistake here? No matching instructor initialization of vector int. Okay, we need another, and we haven't given the name to our vector. So now if I submit this, as you can see, it is working fine. So thank you for watching the video. I hope so that you got something from the video. Make sure you hit that subscribe button, and thank you for watching.